Hi there, I'm Alice, a supply chain systems architect obsessed with making complex networks smarter and faster.
And I'm Bob, your resident ML engineer. I love solving messy problems with clean pipelines and clever models.
Today, we'll show you how Walmart's supply chain, massive and impressive as it is, still faces blind spots.
And how those blind spots lead to stockouts, overstocking, and costly shrinkage, even in the best-run systems.
So let's take a look at where the current system falls short and what we can do to fix it. Concerned. Walmart's current system is powerful, but not always real-time. Stores send inventory updates in daily batches, and shipments are tracked in separate systems, often with limited condition data.
Forecasting engines rely on this delayed, incomplete data, assuming everything is on time and intact. But what if a truck gets delayed, or goods get damaged in transit?
Matter of fact, that's how stockouts happen, even when the system thinks stock is there.
And to avoid stockouts, it overcompensates, sending more stock than needed, causing overstocked back rooms and waste.
Or shrinkage from damage or theft, and you're looking at millions lost, all from visibility gaps and slow data.
What if we could fix that, with real-time data, traceability, and intelligent insight at every stage?
Here's OmniTrace in a nutshell, 5 coordinated stages from edge to action.
First, IoT Edge, millisecond interval sensor reads of temperature, humidity, GPS, and vibration.
Next, data ingestion. We batch and tag data, streaming every 5 seconds into Kafka topics for low-latency processing.
Then comes the blockchain ledger. Each batch is committed via smart contracts to a permissioned Hyperledger Fabric network, ensuring an immutable audit trail.
ML Analytics runs 2 parallel pipelines. Unsupervised models flag anomalies. Supervised models forecast disruptions using fused internal and external data.
Finally, alerts and dashboard. Real-time JSON alerts to MQTT or webhooks, and live Grafana dashboards for every stakeholder.
At the edge, IoT sensors capture real-world telemetry, temperature, humidity, GPS, even vibration, every few milliseconds.
We buffer these into fixed-size arrays, say 100 samples per batch, tag them with a device ID and timestamp, then publish via MQTT into our Kafka topic, sensor raw bads, for downstream processing.
Here's what one batch payload looks like. Next, we commit each batch to a permissioned blockchain, Hyperledger Fabric, via a simple smart contract call.
Our chain code stores the raw JSON under the transaction ID, guaranteeing an immutable, tamper-proof record of every shipment's conditions.
Now anyone with permission, suppliers, auditors, even customers, can verify provenance back to the source. Now ML Analytics kicks in with 2 parallel streams. On the left, an autoencoder in TensorFlow computes reconstruction errors on each batch, flagging any anomalies, like sudden temperature spikes.
On the right, an XG Boost model fuses on-chain sensor history with external feeds, weather APIs, and port delay data, to predict the probability of downstream disruptions in under 50 milliseconds. When an anomaly score crosses its threshold, we emit a JSON alert via MQTT or HTTP to downstream services.
And all events stream into our real-time dashboard, heat maps, time series charts, and live alert logs, accessible on desktop or mobile. Before OmniTrace, visibility gaps meant empty shelves, lost sales, and frustrated customers.
After OmniTrace, real-time alerts and predictive insights keep shelves stocked, boost sales, and cut spoilage.
Plus, on-chain provenance and embedded sustainability metadata build trust with suppliers, regulators, and consumers.
That's the power of an integrated IoT blockchain ML platform, turning blind spots into business value.